Hey guys, today we're looking at pressure volume calculations, which have to do with Gay-Lussac's law. So a quick reminder of what Gay-Lussac's law is. We know that as the temperature goes up, the pressure goes up. And that's because as the temperature increases, we know that means our particle speed is increasing. So our particles are moving faster, they're bouncing off the surface of their container more, therefore the pressure increases, because we know that pressure is a measure of particles colliding with the surface of their container. So particles moving faster means more collisions with the surface, which means greater pressure. So we're going to set up an IFE table again, just like we did with our Boyle's law problems. So here we see the gas left in an aerosol can is stored at a pressure of 1 atmosphere. So pressure of 1 atmosphere. I'm going to write that there. At a temperature of 27 degrees Celsius. Now remember, we need to use Kelvin in these calculations because Celsius can go negative and we can't have a negative pressure. So we need to use a temperature measurement that has no negatives, and that's Kelvin. Remember, 0 Kelvin is absolute zero. You cannot get colder than 0 Kelvin. There are no negatives in Kelvin. So to get our 27 degrees Celsius into Kelvin, we just need to add 273. So if I add 273 to 27 degrees Celsius, I get 300 Kelvin. And so I can come on over here and write that in for my initial temperature. So again, just remember to always convert to Kelvin. And I'm just going to erase this here because we need that space later. But you're going to do the same thing with the 927 degrees Celsius. You need to convert that to Kelvin as well. So 927 degrees Celsius plus our 273 is going to give you 1200 Kelvin. Sorry, I need to write that in pen. So it's going to give us 1200 Kelvin. Now we're looking for pressure. It says, what is the internal pressure of the gas? So I'm going to put my question mark there for pressure. Well, if I look at what's happening for my effect line, from 300 to 1200 Kelvin, the temperature is definitely going up. And according to Gay-Lussac's law, if the temperature goes up, the pressure goes up. The two are, remember, directly proportional. So to find out my new pressure, I'm going to take my initial pressure and I'm going to multiply that by my temperature ratio. Since I need my pressure to go up, I need to put the bigger number on top. So putting the bigger temperature on top is going to make my pressure go up. So I need to make sure that my math matches my IFE table. So if I put that in my calculator, 1 atmosphere times 1200 Kelvin over 300 Kelvin, I'm going to come up with 4 atmospheres. And lucky for me, that works out. I'm only allowed 1 sig fig because of this 1 atmosphere here. And 4 atmospheres happens to be 1 sig fig. So there we go. I'm done. 4 atmospheres to 1 sig fig. And I can always go back and check. So if I were to, let's say, go plug this in here, final pressure is 4 atmospheres. That does indeed go up from 1 atmosphere. So that's a good check. Always make sure your final answer goes in the direction it should compared to your initial value. And that's how you do a problem with Gay-Lussac's law.